Here we have a question 3 that says a light inextensible rope is attached to a vertical wall at point X. A block of mass 2.1 kgs is attached to the other end of the rope. The rope is pulled to the left by a horizontal force of magnitude 28 newtons applied at point Y, as shown in the diagram below. The rope makes an angle theta with the wall. So whatever they've mentioned here, we can actually see it on this diagram. But when you get something like this, there's one main thing you need to understand, that there is going to be a central point that experiences all the forces. Now, if you look at the diagram that we have, that central point that is going to experience the tension in these ropes, as well as the force of gravity, the weight of this block pulling it down, that point is point Y. So you need to understand what your main point is, and in this case, it is point Y. Now let's start off by understanding this diagram and understanding the forces that is going to be exerted on Y. Firstly, we have this 2.1 kg block that is pulling down. So we understand that the force of gravity is going to act down. As they have mentioned, we have a force applied to the left of 28 newtons. And seeing that there is a rope attached to the wall, there is going to be tension. So these are the three forces that we have acting on point Y. Now it's important that when it comes to Newton's laws, before you even read the questions, read the given information, make sense of the diagram that's given, understand all the forces that you are dealing with, and then only read the question. So here we've got these three forces. 3.1 says draw a closed vector diagram to show all the forces acting at point Y and include at least one angle in your diagram. Let's first start off by understanding what a closed vector diagram is. Now this is something that you may have heard in grade 10. You actually should have heard in grade 10 where when you were introduced to head to tail and tail to tail vector representations. So you should have heard a closed vector diagram. What that actually is, we can draw a closed vector diagram where if we take all of the forces that we have acting on our central point, we can create a closed shape. And in particular, that shape is going to be a triangle. So we can draw these forces, and bear in mind, closed vector diagrams are drawn head to tail. So we can draw all three arrows head to tail such that it forms a triangle. Now why do we draw a closed vector diagram? A closed vector diagram is drawn when the system is in equilibrium. What does that mean? That means that the system is stationary. It is not moving. There is zero acceleration. So we're going to try to rearrange these arrows so that they form a triangle. Also at the same time while drawing them head to tail. So I'm just going to try to do it on the left hand side here so that you can see what we're doing. I'm going to choose to start off with tension. It does not matter which one you start off with. Here's my arrow for tension. There's the head of the arrow. Since it is going to be drawn using a head to tail method, the arrowhead of the one force needs to touch the tail of the next force. So the next force that I'm going to choose to work with is Fg. So the tail of Fg, notice, touches the arrowhead of tension. And the last force that we're left with is this force applied, which they are just calling F. So the tail of F touches the head of Fg, and the arrowhead of F touches the tail of T. So notice what this has done is that it has allowed us to draw a triangle, specifically a right-angled triangle. And they asked you to include at least one angle. Your 90 degrees can count as an angle. The reason why this is 4 marks is because you have 1 mark allocated to each vector that you've drawn and 1 mark allocated to the angle. Now at the same time, say that you didn't include the 90 degrees. What you could have included is this angle here that was given. So you could include theta. So this is what a closed vector diagram is. You rearrange your arrows head to tail method to form a triangle. For 3.2, it says calculate, and 3.2.1, the tension in the rope. Now, we need to solve for T. And if we had the angle for T, it would be quite easy for us to do this because we could apply Newton's second law. But since we don't have the angle, what we do have though is, from this triangle, we know what F is, and we're able to calculate FG. So working with this triangle, I'm just going to redraw it to show you. Okay, so this is what we have, and here we know that F is 28 newtons. That was given to us. So if we can calculate FG, then we can actually use the theorem of Pythagoras to solve for tension, since this is a right-angled triangle. So the question is, how do we calculate Fg? Remember that Fg is basically the weight of the object. It's the force of gravity, which is equal to mass times gravity. So the mass was 2.1, gravity is 9.8. We're going to multiply these two together. So we get 20.58 newtons. Let's fill that in on this diagram. Now, seeing that we have these two sides of the triangle and tension actually forms the hypotenuse here, we're going to use theorem of Pythagoras to solve for tension. So we're going to say r squared is equal to x squared plus y squared. I'm going to replace r with t because that's what it is. X is the horizontal part, which is 28. Y is the vertical part, which is 20.58. At the same time, we're going to square root both sides. And when we put this in our calculator, we get 34.75. And remember, tension is going to be measured in newtons. So this is our answer for tension, 34.75 newtons. Now going back up to 3.2.2, they now want you to solve for the angle. And if we look at this diagram, since we now know, let's actually fill in tension, 34.75 newtons. Since we have all three sides of the triangle and we need to solve for theta, we can easily use trig to get this. So notice how this type of question relies a lot on your use of trig, theorem of Pythagoras, and the reason why is because it forms a right angle triangle. So here you can choose any one of the trig ratios. I'm just going to go with tan to solve this. So I'm going to use, in terms of theta, I want to solve for theta, I'm going to use opposite over adjacent. So I have tan theta is equal to, the opposite value is 28, the adjacent value is 20.58. So we learned this in grade 10. We know that if we're trying to solve for theta and we take tan over to the right hand side, it becomes tan to the minus 1. And whatever fraction you have on the right, that goes in the bracket. Okay, let's calculate and see what we get. So we get 53.68 degrees. That is the value of theta. Please remember to like, subscribe, and turn on your notifications for more content.